now on lesson 56. There's several parts to this. The first part is on sets. Second part is rearranging along with graphing. So I'm really going to have to do the two separate parts. But the first one is sets. Relatively simple. It first talks about finite and infinite sets. Finite sets have a limited number of members, like, you know, this set has the numbers 2, 3, and 4, and that's it. Infinite set has an infinite number of members, like this set consists of 1, 2, 3, ... The ellipse is saying that it goes on forever. So infinite finite sets. Then they have membership within a set. That's really what example 56.1 is about. It says represent the following as being members of set K. It don't get much easier than this, okay? So for set K, we would write K equals, with that no school and we still got the bills. Anyway, within this, we just put whatever numbers are in the set, and you only list them once, like even though 7 is in here twice, 5 is in here twice. Within the set, you only need to list them once, and it's good to go ahead and put them in numerical order. So the numbers in our set, smallest one is 0, then 1, 2, 4, 5, and 7. So those are the members of set K. That's all you have to write. It's just those are the numbers that are within that set. And then I'm going to skip over to example 56.3. It gives us an example of 3 different sets, given that set A is made up of 0, 1, 3, and 5. Set B is 0, 4, 6, and 7. And set C is 1, 2, 3, 5, and 7. Are the following statements true or false? And they introduce a new little symbol to us here. It looks kind of like an E or a sideways M. Basically, that little symbol just means it's a member of that set. So this first one is saying 5 is a member of set A. And if you look up here, 5 is a member of set A. So that one is true. If we go to the next one here, it says 4 is a member of set C. And if you look up here, 4 is not a member of set C. So that one is false. And then this last one actually gets a little tricky. The last one says 5 is, I think it actually says it's not a member. I just wrote it wrong, yeah. It says 5 is not a member of set B. So again, this is a true or false statement. So we're looking at set B. 5 is not a member, which is what this is saying. It's saying 5 is not a member, so that is true. So read each one carefully, then you can tell whether it's true or false. Like I said, this one's a little bit longer. The other thing is about rearranging, so we're going to take one little break and then we'll look at that. Okay, for the second part here, it's the rearranging along with graphing. What they're going to do is they're going to put together a few things we already know. For instance, right here, we already know how to solve multivariable equations. That's what we're doing here. We're just going to solve for y. So I'm going to leave 2y on the left. I'm going to leave the positive 4 on the right. I'm going to move 3x over, and it becomes negative 3x. Now, to solve for y, I want to get rid of that 2 that's with y, so I will divide everything by 2. It'll give me y equals negative 3 divided by 2x plus 4 divided by 2, which is 2. So I've now rearranged. I've solved for y. So I've got a new linear equation here. Now we're going to go ahead and graph it, which we've already learned. We're going to make our little chart here, and we're just going to plug in a few simple numbers for x. Now remember, 0 is always a real simple one. When you have a fraction here, you need to work things out a little bit differently. So we will use some simple numbers. 0 is always a simple one. We've got some other ones we could use, -1, +1. Whenever you have a fraction though, what I've said before is it's always good to use the denominator. That gets rid of the fraction. So I'm actually going to use -2 and +2. So first of all, we're going to plug -2 in place of x. So we're going to have -3/2 times -2. A negative times negative is a positive, and we end up with +3 plus 2 is 5. All right, then we're going to plug 0 in. That's real easy. Anything times 0 is 0. 0 plus 2 is 2. And then we're going to do negative 3 over 2 times positive 2. Negative times positive is negative. Negative 3 over 2 times 2 is negative 3. We end up with negative 3 plus 2, which is negative 1. So that gives us our 3 sets of coordinates that look like this. We just need to put them on a graph now, and we're going to have the graph of a line. So negative 2 comma 5. Remember, x always goes first, so negative 2 on x, positive 5 on y. 0 comma 2, 0 on x, 2 on y, and then 2, negative 1, so 2, negative 1, and there we go. We have the graph of our line, and it's always good to label it. This is y equals negative 3 over 2x plus 2. And that brings us to the end of the intro there.